Hey there, math fans. We have the race of the century here between two famous mathematicians. I've taught at the University of Washington for 20 years. I'm teaching pre-calculus right now. Every time I teach it, I look up more history about everything I teach. But in particular, I just looked up more history about the letter E. So if you've always wondered where it came from, I'll say a little bit more at the end. I've already made some videos like this. But this time I thought we'd have a race between the founders of the number E. So in the powdered wig on top, that's Jacob Bernoulli, born in the 1600s, lived in the second half of that century from Switzerland, one of the early founders of calculus. His family did many different things, but he wrote a small article, which I'll show you in a second, about how we compound interest. And he talked about how if you spread out the interest more throughout the year, the number does go up, but it approaches something in a limit. And then he specifically talked about the limit of 1 plus 1 over n to the n. And he said when n gets bigger, yes, the power gets bigger, but also the number inside gets smaller, and there's a balancing act. And so he computed that. So we'll just give you a little taste here of what he did. He plugged in a 2. He plugged in a 3. And I did the translation of the article. I'd never done that before. He used the symbol, like a star symbol, for this number that it was approaching. And you can see it approach 2.56, gets bigger and bigger and approaches this number. And that comes about if students that have taken some finance or something, you've seen that formula before. Typically there's an R in there. So this really all comes from business people. I always say to students, if you don't like the symbol E in the log, don't blame me, blame the business people. They wanted to know about compound interest. There's a longer history that Bernoulli wasn't the first to use this number in some settings. It's often attributed to Napier, a Scottish mathematician who basically invented logarithms, which became very valuable for slide rules and keeping tables of values. But that's more history than I was going to give. So, but Bernoulli just used a star symbol. It wasn't like a major thing. And then along came Euler. So Euler in the puffy hat below and the blue shirt, also from Switzerland, knew the Bernoulli family. One of the Bernoullis was his teacher. But he's one of the most prolific mathematicians of all time, which means his works would fill an entire library, just his writings. Pretty much most of the constants we use today, pi, e, he was the first to use them. And because he wrote so much, it became very well understood. Now, there's this misconception, and I've read this now in many places, that when we're about to have this race, but he wrote an article to one of his friends, Goldbach, who's known for other things. There's this famous Goldbach conjecture, but he used the letter E. So he used it in that article, and then he used it in subsequent writing. Other people used other symbols at the time, but eventually people just did what Euler did. There's no writing or evidence that he used it because of his name. In fact, there's a lot of writing that says he was using A for various other things, and so he wanted to use a different vowel. Also, there's some discussion about how A, B, C, and D were often used as parameters, and so E was like the next available. So people just kept using it. It's not named after exponentials. It's not named after Euler necessarily. We don't know for sure. It just was the next letter, and he wrote and used it. And mostly the history shows that people liked Euler. I don't think he was a prima donna. He didn't have a channel saying, Dr. Lovelace teaches math. Okay, so here we go. We're going to have a little race. Euler found this other formula, which is incredible. 1 plus 1 over 1 factorial 1, that this also approaches E. And because of this, it has these intimate connections with calculus, has many nice facts about it. And so that's why we like to use the base E, because of how nice the derivatives are. But his approaches very quickly, as you will see. In fact, there's writing that says he was able to compute 18 digits of E long before calculators using that formula. Okay, so let's send them on their very slow race. We'll give Bernoulli a head start. Go ahead, Bernoulli. Get moving. Okay, he's moving. He's got 2.25. He's trying to get close to the number E. And now I'm going to send Euler on his way. Oh, Euler's already ahead. I thought I started him behind. He's already at 2.6. Then he adds the fourth one, 1 over 4 factorial. Wow, he's already there. Wasn't a fair race. Nobody can beat Euler in terms of getting to E. So really, after just a few terms of the sum, this is a thing about convergence. A lot of times you'll have multiple formulas that approach the same number, but there's a practical thing of which one approaches faster. And there's a long history of people trying to approximate pi with ever approaching things. I hope that was interesting. I've tried to find this time what Euler used A for, because I've seen in a couple different articles where they say he was using A for a different constant, but I can't find any evidence of what he was using A for. Maybe somebody knows and can find that. Just to wrap this up, so this is the original article written by Bernoulli. This time I threw it through a translator, which I'd never done before. And the translator basically said, it's doing its best, but it showed a spot in the article where he's using the symbol star to represent this limit. So star was the first symbol for E. And then Euler came along and wrote in an article about it, did 18 digits. And then really where this comes up is this is a slide I'm showing here from my business math class. We do compound interest, so you may be aware of this is R, this is P, this is what we call principal, this is the rate, this is the number of times a year that the bank spreads out the interest. And they do two things. They divide the annual rate and they also multiply the number. So here's like 3% compounded, whatever it is, daily, quarterly. And you can see, it's a cool thing. You can see that if they compute the interest twice a year, spread out twice a year, you get this. If they compute the interest spread out 4 times a year, you get a few more pennies that year, 50 cents more, 57 cents more. But you can see quickly that once you start compounding daily, the difference between compounding interest spread out daily or hourly or minutes or years, we used to sing in my class 525,600 minutes because it was from the show Rent. And there was a while that everyone knew that conversion. So lots of dumb things I have to say. My students affectionately call the limit the PERT formula. And everything inside the compound interest formula approaches e to the RT. That's something you can prove based off of the fact from Bernoulli. So from Bernoulli's fact, you can say, if that approaches E, then there's a proof, and I could show that to a calculus student, that not including the T here, if I get rid of the T, that all of this stuff approaches E to the 0.03. And that in general, that approaches E to the R, to the T, because the T is there. So there you go. There's some more history. So it really is the business people you get to blame for this constant. Bernoulli was a mathematician, but he was writing about interest. His was the preface to his article was about gambling. You owe a gambling debt. So E comes from discussing a gambling problem. All right. So there you go. Hope you found that interesting. Let me know if things like this are something you'd like me to make more of.